Hello, ladies and gentlemen. Today we're going to be talking about how to find percentile ranks and percentiles, and we're also going to be talking about how to construct box and whisker plots. So what you'll need is your notebooks, foldables, something to write with, and definitely a graphing calculator because that'll help us a lot with our box and whisker plots. If you don't have a graphing calculator, we'll have some in class, so just follow along so then when you get back to class for your homework, you can borrow one of my graphing calculators from our classroom set. Let's get started. A percentile rank or a percentile is this kind of example. If you say that your percentile rank is 70, that means that you did better than 70% of the group, or 30% of people did better than you did. The percentile rank of a term in a distribution is found by adding all the numbers below the given term and half of the numbers that are equal to that given term. We'll look at the calculation here in a second. Here is the formula to find the percentile rank. So our percentile rank, we'll call it X. The desired percentile is going to be equal to B plus 1/2 E all divided by N and then times 100 to get to our percent, where X is the desired percentile that we're looking for. B is all of the numbers or data values that are below that desired percentile. E is all of the numbers that are equal to that desired percentile, and then of course N is our total number of values in our data set. So given the following scores, find the percentile rank of Jimmy, who scored an 82. So we need all of the data values that have scored below an 82 plus 1/2 of all the data values that were an 82 divided by the total number of data values all times that 100. So let's look at how many scores or test scores were below an 82. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Plus 1/2 times how many data values were equal to 82? It looks like just 1. All divided by how many total data values we had, which was 16, 17, 18, 19, 20. All times 100. So I'll write my next step up here. X will be equal to 15 plus 1/2 is 15.5 divided by 20, all times 100. So 15.5 divided by 20 as a decimal is 0.775. Take that times 100, we get 77.5%. As a percentile, that would be the 78th percentile. I'm running out of room, but you get it. Okay, let's do another one. So this time, Sarah, we're going to look at her score of a 60. What is her percentile ranking? So how many data values fell below a 60? It looks like 1, 2, 3, 4. Plus 1/2 times however many data values were 60 in our data set. That looks like 2 of them. All divided by our 20 total data values in the data set. So 4 plus 1/2 times 2. 1/2 times 2 is just 1. So then 4 plus 1 would be 5 divided by 20. All times 100. 5 divided by 20 is 0.25 times 100 will get us to the 25th percentile. All right, finding a percentile rank of a frequency distribution. So now we don't have the raw data set like we did in the last two problems. We just have a frequency distribution. So remember, with a frequency distribution, we don't know between which ages of 6 to 10-year-olds, how many of them were how many of the 11 were 6-year-olds, 10-year-olds, 5-year-olds, right? We just know that 11 of these people that we surveyed were between the ages of 6 and 10. They could all be 10-year-olds. They could all be 6-year-olds. They could be 6, 7, 9, 8, all those things, right? So how we're going to go about doing this, when we think of the formula, B plus 1/2 E divided by N times 100, we want to find the percentile rank of someone who is 19 years old. So 19 falls in the category of 16 to 20. So the ages that are less than 19 are 6 to 10-year-olds and 11 to 15-year-olds. So how many people were 6 to 10-year-olds? 11. And how many people were 11 to 15-year-olds? 12. So that means that 11 plus 12 is 23. 23 people were less than the age of 19, in that category anyway. Then we're going to take 1/2 times the expected, and our expected is going to be the category that we're in, the 16 to 20-year-olds. So that's going to be 1/2 times 10, all divided by the total number of data values. Our total number of data values is going to be the sum of the frequency column. So if we take 11 plus 12 plus 10 plus 14 plus 18, we should get 65. That's our N. So 1/2 times 10 is 5, so it's going to be, oh, I already did that in my head. Sorry, 23 plus 5. 23 plus 5 divided by 65, all times 100. 23 plus 5 is in fact 28, like I gave away, divided by 65, all times 100. What's that percentile? Let's see. It's going to be equal to 43.08%, which is the 43rd percentile. All right, some terms to know. The 25th percentile is also known as Q1 or quartile 1. It is the lower quartile and it can be denoted as P sub 25 or Q1. It is the median of the lower half of your numbers. The 50th percentile is the exact same thing as the median. So I'll grab my highlighter. 50th percentile is the same thing as the median. It can be represented as P50, Q2, or X with a little tilde above it. 75th percentile is going to be the median of our upper half of numbers, so that will be represented as P75, Q3, any one of those options. And then we're going to use these things to create a box and whisker plot. We're going to reference the 25th percentile as Q1. We're going to reference the 50th percentile as the median and the 75th percentile as Q3, and you'll see in a second. We're going to use all three of those things in order to find a box and whisker plot. And if you've never seen a box and whisker plot, it's a way to organize our data based on the quartiles, 25th, 50th, and 75th, and our highest and lowest values in the data set. So that's going to be our min and max, our minimum value and our maximum value. Oh, I didn't mean to advance. Sorry. So if you've never seen a box and whisker plot, typically you have a number line, and then you have a couple dots, and then you have some sort of box with another line inside the box, and then you have these lines connecting the box to those two dots. So what each of these things is going to represent, here I'll grab another color. This is going to be your minimum value, that dot, that whisker. Your maximum value is going to be the other whisker. So your whiskers are going to be your min and max. And then your quartiles are all going to be part of the box. This is going to be Q1. This is going to be your median. And this is going to be Q3. So finding Q1, Q3, and the median and the min and max is what we need to find in order to create a box and whisker plot. So we are going to construct a box and whisker plot for those following data values that, using those same data values that we did in the first two examples to find Jimmy and Sarah's percentile ranks and their scores, we're going to construct a box and whisker plot from those data points. Instead of using or doing all the calculations by hand, we're going to use a graphing calculator to help us find the minimum, maximum, the Q1, Q3, and our median. So what you're going to need is a graphing calculator. Again, if you do not have one, you'll have some access to graphing calculators when it comes to the homework when we get back to class together. You're going to go to the Stat button, you're going to hit Enter or Edit, and then you're going to enter all of the data values in this list. So 99, 88, 88, 85, 82, 81, 80, 78, 77, 75, 74, 68, 62, 61, 60, 60, 58, 44, 42, and 20. I'm just going to take a quick scan back through the data values to make sure I didn't miss any digits. It looks good. Then we're going to go to stat. We're going to arrow over to calculate the 1-var statistics. I am in list 1. I'm going to hit calculate. And if I arrow down, it gives me everything I need to know. It gives me the minimum, the maximum, the Q1, the median, and the Q3. So the minimum was 20. I'll have to grab a pen here. Min was 20. I'll put my max over here. My max was 99. I guess we could have found that from the data set, I guess. Q1 was 60. The median was 74.5. 74.5. And Q3 is 81.5. So typically for our homework assignments, I'll give you a number line to go alongside for your box and whisker plot, but I didn't have one provided for me. So we will start at 20 and we'll go up by tens. Here's 40, 50, 60. I'm trying to make them spaced somewhat equally, but it's not working the best. Here's 100. Okay, so our minimum is 20, so that's a dot. Our maximum is 99, which is right about here. Our Q1 was 60, so that's the bar of one side of our box. Q3 was 81.5-ish, and our median was almost 75. So then connect your box to your whiskers, and that is our box and whisker plot. So we can use percentiles and percentile ranks, that Q1, Q2, Q3, to create box and whisker plots. And then obviously we can just find a percentile using those formulas that we did at the beginning of the lesson. So I want to thank you all for taking good notes, and I'll see you soon.